In problem number 21, we're asked to identify the horizontal and vertical asymptotes. The first thing I'm going to do is I'm going to put this, if it's possible, into factor form. So r of x, what multiplies to give us negative 8 and combines to give us a negative 4 would be minus 4 and positive 2. On the bottom, what multiplies to give us a negative 6 and combines to give us a negative 1. That'd be a minus 3 and a positive 2. Let's start with the horizontal asymptote. In this case, there is a horizontal asymptote that exists because the degree in the numerator is equal to the degree in the denominator. So when that occurs, we're going to look at the leading coefficients and we're going to divide them. So 1 divided by 1 is 1. So we have a horizontal asymptote at not just 1, it's the equation y equals 1 that represents the horizontal asymptote. Again, not just the value 1, it's the equation y equals 1. Okay, next I see that we have a common factor in the numerator and in the denominator. So I think there's a potential hole here. So I'm going to take this factor, set it equal to 0, and solve. I believe that there's a hole at x equals negative 2. Now, how can I be certain about this? Well, if there's a hole that exists, it's going to have a corresponding y value. And taking now the simplified form, which is x minus 4 over x minus 3, I can plug this back in. So, excuse me here. Negative 2 minus 4 over negative 2 minus 3. And I end up with negative 6 over negative 5. Two negatives make a positive, so 6/5. So because there exists, this is not a negative, that's just where the line was for me to place a y coordinate. Because a y coordinate exists for that hole, this means there is a hole here at x equals negative 2. Now, the last thing we're going to do is identify the vertical asymptote. From the simplified function, I take the denominator, which we have a factor of x minus 3. I set it equal to 0 and I solve. And so we have a vertical asymptote with the equation x equals 3.